Good afternoon, students. Today I am going to start exercise 1.4, and which exercise is based on binary operations. Now the first question is, determine whether or not each of the definition of given below gives a binary operation. In the event that star is not a binary operation, give justification for this. And first question is, on Z plus the set of all positive integers, define star by A star B is equal to A minus B. Now we have on Z plus star is defined by A star B is equal to A minus B, and we can see that if we take 1 and 2 as positive integers, then since 1 star 2 is equal to since A star B is A minus B, therefore 1 star 2 is equal to 1 minus 2, and which is equal to minus 1. But minus 1 does not belong to Z plus. We can say that this implies it is not a binary operation, because minus 1 does not belong to Z plus. And this is the we can also say that the image of 1 2, the image of one ordered pair 1 comma 2 under image of 1 2 under star is not a positive integer. Therefore, it is not a binary operation. Now we solve third part of this question. On the set of real numbers R, define star by A star B is equal to AB square. We see that on R, star is defined by A star B is equal to AB square, and it is seen that for each A comma B belongs to R, there is a unique element AB square in R, because if we take A or B any real number, then AB square will be unique element, and that unique element will belong to the set of real numbers. Therefore, we can say that it means star each pair A comma B to a unique element AB square in R, and therefore star is a binary operation. We can solve all these questions, and we solve one more question from question first, and which is third question. Which is fourth question, and fourth question is on Z plus the set of positive integers define star by mod A star B is equal to mod of A minus B. Now we see that on Z plus star is defined by A star B is equal to mod of A minus B. Now if we take 1 star 2, then we can write mod of 1 minus 2, and this is equal to mod of minus 1, and mod of negative integer will be positive, therefore it is 1, and 1 belongs to Z plus. It means that star carries each pair A comma B to a unique element A star B is equal to mod of A minus B in Z plus. Therefore we can say that it is a binary operation. This implies it is a binary operation. Now let us see question number 2. Second question is, for each binary operation star defined below, determine whether star is commutative or associative. And the first question is, on Z the set of integers define A star B is equal to A minus B. Now we have on Z star is defined by A star B is equal to A minus B, and we can see that 1 star 2 is equal to 1 minus 2, and which is minus 1. But what about 2 star 1? 2 star 1 is equal to 2 minus 1, and which is equal to 1. And we can see that 1 star 2 is not equal to 2 star 1, since 1 star 2 is not equal to 2 star 1. 2 star 1 for all 1 comma 2 belongs to Z. We can say that hence the operation star is not commutative. Because we know by the definition of commutative operation, if A star B is equal to B star A, A star B is equal to B star A, then the operation will be commutative. But here A star B is not equal to B star A. That's why A star B is not equal to B star A. That's why this operation is not commutative. And again, we have to show that this operation is, we have to check whether this operation is associative or not. Now, it can be observed that it can be observed that 1 star 2 star 3 is equal to 1 minus 2 star 3, and which is equal to minus 1 star 3, and we can write which is equal to minus 1 and minus 3, and which is equal to minus 4. And also 1 star 2 star 3 is equal to 1 star 2 minus 3, and which is equal to 1 star minus 1. But 1 star minus 1 will be 1 minus minus 1, and which is equal to 1 plus 1, and which is equal to 2. We see that hence for all A, B, C belongs to Z plus A star B star C is not equal to A star B star C. A star B star C. Therefore, star is not associative. Star is not associative. By the definition, we know that for associativity, we must have A star B taken together, and star C will be must be equal to A star B star C taken together. That's why we have shown that A star B, the operation given is neither commutative nor associative. Now we can also solve this question as on Q the set of rational numbers, define A star B is equal to AB by 2. Here on Q star is defined by A star B is equal to AB by 2. Now what about B star A? B star A will be since B star A will be BA by 2, but AB is equal to BA because the product of rational numbers is commutative. Therefore we can write this as AB by 2. Since A star B is equal to B star A, therefore it is commutative. It is commutative. Now we have to show that this operation is also associative. Now if we take another rational number Q, then A star B star C is equal to A star B is AB by 2 and star C A star B is AB by 2 and suppose that we are taking star C, then we can write AB by 2 into C by 2, and this is equal to ABC by 4. ABC by 4, because A star B is AB by 2 by the definition, and if we take the operation between two elements AB by 2 and C, then we have AB by 2 and into C and by 2, and it will be ABC by 4. Now A star B star C, and this is equal to A star B star C will be BC by 2, and we can write A star BC by 2. We can write A into BC by 2 and by 2 by the definition of A star B, and we can also write ABC by 4 because the product of rational numbers is commutative and also associative. Therefore we have, since A star B star C is equal to A star B star C, therefore the the operation is also associative. Now in the next video we solve more questions from this exercise. Thank you, students.